Y'all, I'm telling you, do your homework, baby. Be ready for school. This stuff is so real till it's unreal how real it is. Let's see. I had some stuff up here I want to share with you right quick before I get into my program. And it's got a little something to do with this program, but it's just like off the top. But I don't know if anybody ever heard of the Egyptian Turin Papyrus, but what it is a bunch of sex scenes. Can you see that? Bunch of sex scenes. I'm still ghetto fabulous with my phone and the computer. I ain't learned how to turn it in and out and all of that. Mirror, mirror. I ain't got it down pat yet. Can you see that? Sex positions. This is sex magic, y'all. This is Crawley and Rihanna. See, that's a white horse. What they did with the white horse? It was some white horses in here at one time. See, this Mandela effect and all this, I'm finding out. But right here on this chariot, I know I peeped this like years ago, this Egyptian Turin Papyrus. Right here where this chariot is at, it used to be some white horses right there too. I don't know where they at, where they done went to, why they not there no more. But I know Rihanna said, F your white horse in a chariot. You needed me. You needed me. Rihanna is pissed. Okay? Because they do. They need us. They need us. This is another one I wanted you to check out. And checking out this quantum matter that this whole world is going into blindly, I found out it has an Alice in Wonderland effect. This is part of the Egyptian Turin Papyrus too. What's trippy about this is a bunch of animals. You can see these animals on coat of arms. These animals are human-like. Only thing I ever noticed about them is that they were human-like. I'm like, okay, what's up with that? But in Alice in Wonderland, they say that's what quantum matter is really based upon, a world like Alice in Wonderland or the Wizard of Oz. They call these parallel universes, worlds inside of worlds. This is what they tampering with. And how she go little and small and big and tall. But I noticed in Alice in Wonderland, I had to watch it after checking all of this out. I fell asleep watching it. How the animals were all human. What if in another world it go down just like that? But we getting ready to get off into that. But before we get off into it, I just want to bring a little music. Y'all know I loves me some Lauryn Hill. And I think I'm going to kick off The World is a Hustle. A hustle. Hustle, hustle. A hustle. Hustle, hustle. I'm going to be quiet and let her sing it. A hustle. I be trying to be light about situations because really, we into some heavy stuff right now. We too far gone. There's no way back. Too far gone, and there's no way back. We're just gonna listen to a little Lauryn Hill right quick, though. We're gonna check out. military hustling us out of everything. Our mind, our bodies, and our souls. We in trouble, y'all.
A world spotlight in the light. Only come back to the
Can y'all hear that?
what we see before our eyes. Yeah. Running after that on television show. Just a picture perfect life. They say only life we know. And it's uncomfortable reality. Got me chasing reality. And the face to faces killing me. But I so willingly practicing. Just like my friend, when the whole world is so exactly where we arrive in this manufactured life. Sell my soul just to survive. Yes, in the game of number time. Must thank the gods who made the street of all the opportunity. Or I display such loyalty. Yeah. Oh, from the way they exploit me. I'm too concerned outside of this. Just like a splinter in my mind persists. But the ministry of fear exists only to keep me from knowing the truth. Still my youth, though, when the whole world is so singularity. Only the hour space to fear me. Only can do something with this greed in me. And I wanted to address this need me. Although I must confess the pride I keep. Protect these infants, my friend. Oh, we will end.
And I'm just going to bring Lauren down a little bit because I need to get started. I don't want to run out of time and I don't want to be pressed for time. You understand? All right. So now, quantum. Quantum matter. A qubit. That's QUBIT, bit. Then a bit being a binary, the things that they use on this regular computer. This gonna get freaky, y'all. Then you got your qubit, which is the measurement, CUBIT. Then you have qubit, CUPID. The Cupid shuffle To the right, to the right, to the left, to the left. Now walk it by yourself. You're going back and forth. You have just made a cube. And then you got your cube. And the D wave is a cube. So it's about this little square box. This little square box. And the last video I did, I ended it with Elon Musk asking, what's outside the simulator? This is what he would ask a computer system if he ever had the chance. What's outside the simulator? Yeah. This is so scary. It's scarier than I imagined. But when I went to dig in to see what in the heck is this talk about this simulator. This is a scary place to be right now, y'all. It's a scary world we in. These some scary people we got holding us down. And I'm just gonna do a little video from Jordy Rose. Now, how come I don't have volume? Are you serious? Now, we just got through listening to Lauryn Hill. So ain't no reason why we shouldn't have VO, right? Y'all pray for me, y'all. Oh, I turned it down.
50 companies. And this is a very prestigious list. It's very hard to make it. But the thing that was distressing about it is that they have this...
We just want to get on to the good part.
I thought was funny. One of the interesting things that happened from the D-Wave story is there's this gigantic conspiracy that's arisen on the internet that goes like this. So D-Wave builds quantum computers. The way that they work, if you know how this works, is one of the interpretations is that you tap into these parallel universes and you do computations. Sounds really weird. But what's happened is this idea has been hijacked to describe something called the Mandela effect, which is this thing where the past changes. So think about something you know to be true from the past. And then imagine you went out on the internet and you can't find it at all. It's not there. It doesn't match with your experience. So these people think that D-Wave is responsible and CERN. And of course, the quantum key to the abyss factors into it somehow. I'm not exactly sure how. Okay, so that's just D-Wave. I did that for about 15 years. It was a lot of fun. Big science project that we turned into a commercial.
I just want to pause it right there. See, so now we know what Mandela effect is. It's them tampering with the universe. This is how come we go into the Bible and we can't see where words used to be in the Bible. They're not there no more. It's because of quantum matter. It's because of the key to the abyss. Did you hear him? They talking real creepy here.
Entity. That was a warm-up for Kindred. So Kindred is much, much, much more ambitious than D-Wave. And what Kindred is trying to do is build real AI. So what you've heard about AI is not what we mean by AI. What we mean by AI is a software system that can do literally anything that a human can do. Literally anything. And obviously, computers are better at things than people in lots of different ways. So now imagine, not only can they do everything that a human can do, but they can do everything that the best human at any task could do better than them. So imagine there was the mental Olympics of the 100-meter dash, and Usain Bolt is the fastest person. Now imagine that's some kind of a mental thing, like writing a novel or writing whatever. Imagine now that the thing is so much faster than Usain Bolt, like, for example, it's a spaceship, yeah? It's still doing the same thing, but it's doing it so much better because we're limited, because we're people. So what Kindred is trying to do is solve this problem. How do you build machines that are better than people at everything? Now, there's a mental block that we have here when we think about this. Because when you think about that, one of your questions might be, for example, what are the applications of this? Well, the applications of this are, for example, if you think about the Tsunami, the Tsunami is a massive, massive So imagine this. Imagine for $10, let's say, I could build a machine, like a little robot that had fingers and eyes and all that, and it could do your job better than you, no matter what it is, and I could sell that to your employer for, say, $15 and make a profit, instead of having to pay you $100,000 a year. Now imagine that was true for every single job. So that's what we're talking about here, is a complete and utter transformative change that of the likes of which has never been seen before in the history of humanity, making the Industrial Revolution look like a little tiny blip on the path that humans have taken from when we emerged from the ooze a few billion years ago. We are right on the verge of that transition now. So this guy, Rich Sutton, is one of the most famous people in the academic world of AI. And like many, when asked, when will...
And I'm just going to go back because I remembered that Elon Musk said something at the beginning of this. Now, I don't know if you can see that screen behind him, but he is talking about super intelligence. These are aliens. This quantum matter are actually aliens. Remember, I keep telling you, they fail with their wisdom. This is how come they're smarter than this. But this gets creepier and creepier because they're actually telling us this isn't anything that needs to be developed. It is already. But it says super aliens, super intelligence, aliens approaching Earth.
Company on the list that was from Canada. Not a single one, which was a little surprising.
Coming to Earth. Super intelligent aliens coming to Earth.
We were from San Francisco because we have an office there, but we're not. We're from here. 3 years ago, the previous company that I founded, D-Wave, also made the list. And it was also the only company from Canada that was on the list at that time. So I've been trying to build the tech community in Vancouver for 25 years. And I find it super depressing that it seems to be so hard to generate world-changing 0 to 1 companies around here. You know, I think that I'm gonna just pitch this idea. Some of you may have seen me talk about this before, but we have this problem here that we don't think big enough. We've got all of the ingredients to create this massive, massive thing in Vancouver, and the spark is not being lit. So I implore you, if you're entrepreneurs, people who are thinking about what you want to do, think bigger, because we don't think big enough around here. Okay, so my previous company was D-Wave. I'll just show you a couple things. We built what are still the world's only quantum computers that you can buy. And the
so
company D-Wave has been doing
they
this.
They have made it. They've made
I didn't really
this
have much to
computer.
do with it, but you know. So this is one of them. This is one of the processors. And a lot of interesting things happened to me over the years there. I got sent pajamas, a whole bunch of stuff. You know, there's lots of interesting things that happen when you build something like a quantum computer. But just as an aside, because I thought it was funny, one of the interesting things that happened from the D-Wave story is there's this gigantic conspiracy that...
I'm sorry, I already let you hear that part.
So we had
somewhere on here
aliens. But before I do that, we had a little bit of interesting news today that's Kindred relevant, and I wanted to share it with you because I'm pretty proud of it. So Kindred was named to a list of MIT's smartest 50 companies. And this is a very prestigious list. It's very hard to make it. But the thing that was distressing about it is that they have this map that they show of where all these companies are from. And there wasn't a single company on the list that was...
I can't find it. I don't want to waste too much time trying to find it. But Elon Musk says that what they are actually doing is conjuring demons. He has it up on the screen here somewhere. I don't know why. It's always like that when you're looking for something. Let me move on here, though, because I don't want to waste too much time. and get to some of these key points. These people, and they know they creepy. They know they tripping.
Like us. So alien means, different. These things that we're building are not going to be people. They might be really smart. They might be really good at all sorts of different things, but they're not going to be like us. They're going to be aliens. And they're going to be, I'm sorry to say, way smarter than every single person in this room in ways that we can't even comprehend. So this, of course, triggers a lot of alarm. One of the guys who talks about this is Elona, who says things like this.
There you go.
Like, when you do this, beware. Because you think, just like the guy in the stories, that when you do this, you're going to put that little guy in a pentagram, and you're going to have your holy water out, and you're going to wave it at the thing, and by God, it's going to do exactly what you say, and not one thing more, but it never works out that way. So this is an attitude that some are having, this emerging alarmism about the way this is going to go. But these words, demons, doesn't capture the essence of what's happening here. I don't know if any of you are turn of the century weird fiction fans, but there's this guy named H.P. Lovecraft, who's a very famous American weird fiction author. And he espoused a view which is called cosmicism. And the essence of cosmicism is cosmic indifference. So what he was saying is basically, yes, there are these massively intelligent entities out there, but they're not good, they're not evil. They just don't give a shit about you even in the slightest. The same way that you don't care about an ant is the same way they're not going to care about you. And these things that we're summoning into the world now are not demons, they're not evil, but they're more like the Lovecraftian great old ones. There are entities that are not necessarily going to be aligned with what we want. So this transition is really, really massively important for our entire species to navigate. And going back to that thing that Sam Harris was saying, nobody is paying attention. This thing is happening in the background while people bicker about politics and what's going to be in the healthcare plan in the US. And underneath it all is this rising tsunami that, if we're not careful, is going to wipe us all out. So, on that pleasant note, we're hiring people to try to make something like this happen.
They crazy. A tsunami of beings, aliens. They're not good or evil. A tsunami sound like the bottomless pit to me. They're going to walk up on this earth. We need to wake up, y'all. We need to wake up. And they hiring people so they can make this happen. Oh, my God. Oh, my God. I bet they paying moolah, baby. I'm talking about, I bet you get paid some money. And this is the last little piece for him. I got to keep it moving. Let's see. The guy asked the question.
You have to make up your mind yourself.
Check this out.
My general comment is that people always miss the future. It's this old thing that people are always saying things will go faster than they do in the short term and slower in the long term. But it's kind of, for me, it's an obvious thing. I mean, this isn't about, the only question is how long it will take. I encourage you to watch that Sam Harris TED Talk if you're interested in this. But the point that he makes is that as long as certain things that are probably true hold, this will happen. Will progress continue? Maybe it won't. Maybe the Earth will get hit by a meteor and we'll all die. If progress continues, things that we're doing, intelligence isn't magical. It's not some kind of weird thing. It's a mechanical outcome of the way that our machines in our head work. We're going to figure it out eventually. And when we do, we're going to make it better in all sorts of interesting ways. And then you have this weird thing that happens that because the machine is now able to act in its own self-interest, it can take the action to make its own thought process better. We can't do that. So we're stuck with what we were born with, more or less. We can learn things, but that's not the same as getting smarter. So these machines are going to be able to take control of the tools from which they are built to create better versions of themselves. And that, what's sometimes called an intelligence explosion, is something that biological creatures can't undergo. So I think it's an absolutely guaranteed outcome of progress. The only question is when, and I think Andrew would agree with that.
James?
Did you hear that? They are going to be able to take what man gives them, and they are going to be able to improve on them own selves. What? They have got to be kidding. People better wake up. It's time to wake up, sleepwalkers. It's time to wake up, sleepwalkers, 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 sleepwalkers. Oh my goodness. Now I know I saved this video last night. I made it my business to save this guy's video last night. That's all right. We're going to get this thing popping anyway. This is Mr. John Preskill.
I joined the Caltech faculty in 1983. Dick Feynman was 65 at the time, just a couple years older than I am now, and he was still very active intellectually. We had some common interests in elementary particle physics, so we had a lot of fun talking about science in those days. And it happened that during my first...
I want to pause that, bring that back, let you check that out.
Was 65 at the time, just a couple years older than I am now, and he was still very active intellectually. We had some common interests in elementary particle physics, so we had a lot of fun talking about science in those days. And it happened that during my first year at Caltech, Feynman was teaching for the first time a course he had developed on the potentialities and limitation.
There it is. That's what I want you to see. It says, nature isn't classical. Damn it. And if you want to make a simulation of nature, you better make it quantum mechanical. What in the heck is he talking about? Think I'm lying? There we go. Whoop, there it is. You can pause the screen right there. Of course, I'm going to lose light and all of that good stuff. Pause it right there. That's what he said. So what are they doing? They are mimicking nature. They are mimicking physics. This thing gets creepy.
Computing machines. As we heard from Michelle, he had been fascinated by computation since his days at Los Alamos. And in the 1980s, Feynman was developing a new vision, what he called a universal quantum simulator. Nowadays, we usually call it a quantum computer. Feynman foresaw, back in the 1980s, as few did
Make this time, for what?
The dawning of a new age in physics. And now, years later, technology is catching up with Feynman's dream. So what is a quantum computer? It's a computer that processes information using principles of quantum physics that were discovered in the 20th century. And you might think that means it's a computer much like the one you have now, only much, much faster and much, much smaller. But that's not the right way to think about it at all. Quantum information is nothing like the information we're used to thinking about. Quantum is different. But what's so different about it? An ordinary computer processes bits, where a bit could be a switch, which is either on or off. And a quantum computer processes what we call quantum bits or qubits, where like a bit, a qubit can be realized physically in lots of different ways. It could be carried by a single atom or electron or a particle of light, or a more complicated object like a cold circuit in which many electrons are moving. So an ordinary computer processes bits, a quantum computer processes qubits. What's so different about that? Well, the thing that makes qubits really different from ordinary bits, and a quantum computer very different from an ordinary computer, is what we call quantum entanglement, from which one entangled evening gets its name. Entanglement is the word that we use to describe the characteristic correlations among
Are they serious?
nothing like the information we're used to thinking about. Quantum is different. And what's so different about it? An ordinary...
That's my point. I had to go back and listen. They are saying that right now, the computer is either on or the computer is off. Okay? The way it stands now. With a Q bit, quantum bit, it is in two states at one time. It is both on and off at the same time. Really? What are y'all messing with? What are y'all doing? What are y'all doing? Do y'all know what y'all doing? I don't think they know what they're doing. I don't think that they know what they're doing. I don't think they even know. We're going to check out this little chick. She gives us the mathematics
Quantum
of a
computers
qubit.
don't exist yet, at least not physically. But
I don't know what world she in. They don't exist yet.
Where they do exist, we can learn how they might work. Let's break down the mathematics of a quantum computer in 3 parts. First, what is a quantum computer doing? Second, how do we represent it mathematically? And third, why is quantum computing so amazing? Part 1, what is a quantum computer doing? The fundamental unit of a classical computer is a bit. Bits have 2 states, 0 and 1. Computers take in a string of bits. In this example, it's a string of 8 bits, and use logic gates to switch some of the bits, like this. Okay, that's kind of a crude description of a computer, but it works for our purposes. Quantum computers use qubits, a portmanteau of quantum and bit, which is kind of funny because bit is a portmanteau of binary and digit. Anyway, like a bit, a qubit can be in state 0 or state 1. And like a classical computer, the initial program for a quantum computer.
So, now let me explain. If the light is on, it's at, if the light is off, it's at 0. If the light is on, it's at 1. What we're dealing with here is what's between 0 and 1. The thing about it is they say that these halves, 1/2, this half, this third, this fourth, they are very fragile, but they are what they call the super status. I forget. They finna tell us in a minute. She finna break it down. But I just want to give you my simpler version of all of that. What they
It's just a string of 0s and 1s. But while a quantum computer is running, its qubits can also be in infinitely many superpositions between 0
superpositions,
and 1.
that's the word.
When a qubit is in a superposition,
some made up stuff.
It has some probability of being in state 0 and some probability of being in state 1.
It got the 8, the infinity in the middle.
Superposition as being a limbo state, partway between 0 and 1. But superpositions are fragile. If we look at it or try to measure it, the qubit will collapse into a basic state, either 0 or 1. You might know this from the famous Schrodinger's cat thought experiment. Before opening the box, the mythic cat is in a superposition of alive and dead. But when you observe the cat, it is forced to pick a state, alive or dead, not both. A quantum computer is essentially full of Schrodinger's cats.
But
actually,
in the quantum world, a cat can be both dead and alive.
Usually things like electrons, where spin up corresponds to state 0 and spin down corresponds to state 1. But I've digressed. That's the realm of physics. Let's see an example of a quantum computation with 2 qubits. There's 4 basic states, 0, 0, 1, 0, 0, 1, and 1, 1. These are the states that 2 classical bits can be in. But there are also infinitely many states formed by superpositions or combinations of these basic states. Each operation of a quantum computation is performed by a quantum gate, which, like a classical gate, changes the state the qubits are in. Let's start our quantum computation in state 0, 0, and then apply a quantum gate. Now, the qubits are in a superposition. There's a 1/2 probability, or 50% chance, of being 0, 1, and a 1/2 probability of being 1, 0. Ignore the square roots, I'll explain them in a minute. The particular superposition it's in is a result of the quantum gate we chose to apply. Here's one more quantum gate, changing the state of our computation. At the end of the quantum computation, we observe or measure the system. But we can't see these delicate superpositions. Remember, a superposition is like a limbo between basic states. When you observe the computation and look at it from the perspective of these basic states, it must pick one, collapsing the wave function and revealing a single basic state. In this case, it collapsed to state 0, 1. If you run the same computation repeatedly, the final result will be 0, 1 half the time, it'll be 1, 0, 1/6 of the time, and 1, 1 1/3 of the time. That's what the numbers in the superposition tell you, the probability that the superposition will collapse into each basic state. So, if you run the computation 100 times, roughly 50 times it'll result in state 0, 1, 17 times it'll result in state 1, 0, and 33 times it'll result in state 1, 1. This allows you to recover the probabilities and therefore the final superposition of the computation. This doesn't seem very efficient with 2 qubits, but as we'll see later, it can save you a lot of time with more qubits. So what's the math behind all this? Part 2, mathematical representation. A vector can be a pretty abstract concept in mathematics, but for our purposes, we'll just say a vector is a list of numbers, and the dimension of that vector is the number of numbers in the list. Here's an important caveat. For now, to help us get through the first part of the explanation, we'll only work with non-negative real numbers. But actual qubits use negative or even complex numbers. But I'll get back to that later. One qubit is represented as a 2-dimensional vector. This is state 0, and this is state 1, and this is a superposition. Here's the reason for the square roots. We can visualize the vector on a circle like this. The horizontal component is the square root of the probability of being in state 0, and the vertical component is the square root of the probability of being in state 1. By the Pythagorean theorem, the length of the vector is 1. Each point on the unit circle is a quantum state. A classical computer can only point
each point is a quantum
point.
point.
A quantum computer uses much more of the circle. What about 2 qubits? It takes a 4-dimensional vector to represent the 4 possible states. Here's the earlier computation in vector form. The formula for the length of a 2-dimensional vector easily generalizes to the formula for the length of a 4-dimensional vector.
Wow, 4D.
So,
we already in 4D, y'all.
All the quantum state vectors have length 1. The 2-dimensional vectors pointed to a spot on the unit circle in two-dimensional space. And these four-dimensional vectors point to a spot on the unit sphere in four-dimensional space.
Bam.
Which makes it awfully hard to visualize.
Awfully hard to visualize.
If you have n qubits, there are 2 to the n basic.
And I'm just going to stop it right there. You can pause it right there at that sphere. And those points that's on the sphere, I would call those ley lines. The points on the sphere. Wherever you at on the point of the sphere, the universe is the world that you're in, the dimension that you're in. That's what brings about the Alice in Wonderland theory. Now, let me tell you some things that I noticed about Alice in Wonderland. Of course, we all know that Alice in Wonderland was big at some points, and then the door was small. She would go through a door, a gate. It would be a different world. Wherever she was at the point on the universe is, I always thought she was tripping on drugs. I thought it was a psychedelic thing. This is about quantum matter. Wherever she was at on the point of the sphere, wherever she was at the point of quantum, whether she was between 0 and 1 and at 1/6, then that made her be in that dimension. This is quantum matter. This is quantum matter. This is Alice in London. She cried. She was in her own tears. She got so small because we went to a different point on the sphere of the universe. We were at a different point on the universe. I don't know about y'all, but I'm concerned. I'm concerned. A sister like me concerned. This is also John Preskill.
When I was in high school, I didn't try out for musical theater. I was doing
He
science.
made a little song about the Cupid's entanglement. How sick.
This was my one chance to sing in front of 1,000 people. Well, now that you got me out here again, I was just thinking that last month was the 50th anniversary of Richard Feynman's Nobel Prize for his work in quantum physics. And there was another significant 50th anniversary that we recently celebrated, the anniversary of Gordon Moore's visionary prediction that integrated circuits would improve exponentially. According to Intel, if your car had improved as the chips had, you'd now be driving 300,000 miles per hour. You'd be getting 2 million miles per gallon, and that car would cost you 4 cents. And actually, it was decades of basic research on the quantum physics of materials that set the stage for Moore's law. But no one knew in 1965 how our digital technology was going to transform our lives. And now we're again at the beginning of an era, the quantum era, where it's particularly hard to predict where it's going to take us. Industry is arriving.
They don't know where this thing gonna take us.
Tomorrow at Caltech, we'll be hosting a quantum summit with participation by some of the companies that are currently investing in quantum technology. Companies like these are eagerly hiring quantum scientists from places like Caltech. But most likely, the really big societal impact of quantum technology is still decades away. But Feynman liked to say it's fun to imagine. So Even though we know our predictions about the future are bound to be far off target, let's think about some of the things that we've imagined that might occur in our quantum future. Prediction. In the future, credit card fraud will be a distant memory. You'll carry a quantum card, which can be verified, but can't be copied. With classical bits, anything that you can read can be copied. But quantum is different. The laws of quantum physics say that qubits can't be copied. There are new possibilities for encryption. Your Q card can be validated by a legitimate merchant, but a rogue merchant wouldn't be able to copy your data. Prediction. Non-invasive quantum sensors probing the brain at the molecular scale will illuminate the foundations of consciousness. We tend to think of the brain in terms of its connectome, how the neurons are wired together.
They're going to connect to our brains.
But
y'all brains, because I'm going to be up out of here. Lord, come quick.
As well. A lot of information processing is going on at the level of individual neurons, or even shorter distance scales. With quantum sensors, we'll be able to probe that activity with unprecedented sensitivity and
gonna probe my brain.
And that's going to teach us things about how the brain works.
Or y'all brain. They're going to be probing brains, baby.
Optical telescopes sharing quantum entanglement will image distant objects with unprecedented clarity. We discovered thousands of planets in just the last few years. We'd like to be able to see what's going on there. Well, in principle, if you wanted to see an elephant on a planet which is tens of light years away, you could do so with a telescope which is as large as the Earth's orbit around the sun. That sounds like a lot to ask. But what we can imagine is an array of satellites in solar orbit, each one carrying a small telescope, but where the telescopes share entanglement. And that shared entanglement allows the many small telescopes to behave like one big telescope that can see faraway objects in very fine detail. Well, the catch is that if you really want to see an elephant on another planet, it would have to be a very, very bright elephant. But the point is that by using entanglement, we'll be able to see more clearly. Prediction. In the future, we will make use of solar cells that exploit quantum effects to power the Earth. Solar energy is our best hope for a sustainable power source for human civilization, but today solar cells are not optimally efficient. We now know that some living things, some bacteria, actually make use of quantum effects to improve their light-gathering efficiency. And we can learn to do the same as our knowledge of quantum materials advances. Prediction. In the future, quantum physicists who have been playing quantum games since they were 3 years old will not be able to understand why 20th century scientists thought quantum mechanics was weird. Our digital technology has launched a gaming culture which continues to accelerate. With quantum technologies, we'll be able to play new kinds of games that we haven't imagined before. And kids will play those games. And they'll develop a visceral understanding of quantum physics that we lack, and that will lead them to new discoveries. So far I've been talking about technology, but I'm not an engineer, I'm a physicist. And so what really interests me is the ways in which our advancing knowledge of quantum information can lead us to new paradigms for thinking about nature.
Listen up, y'all.
To a physicist, what's really important about quantum computing is that we think, though we don't know this for sure, that a quantum computer would be able to efficiently simulate any process that occurs in nature. And as Krista explained, that would mean we'd be able to understand properties of complex molecules and exotic materials. But it also means we'd be able to explore fundamental physics in new ways, say by simulating.
They think. They know. They know that quantum matter can mimic anything around it. The only thing is that it gets fragile in its superposition when it's at its one sixth point, or its 1/4 point, or its 1/3 point. It gets fragile in its superposition. But it can go from little itty bitty bitty to big, 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 and mimic anything around it. So this thing can mimic Earth. That's why Elon Musk is asking, what's beyond the simulator? And why in the heck is he asking what's beyond the simulator? If this is supposed to be 13 years out, so a lot of these videos was back down to 2014, I looked to see. So we still got a few years before we're supposed to be coming into this technology. But Elon Musk is talking about the Tesla coming on the market next year. Somebody lying. This simulator, these aliens, this quantum matter is getting ready to take over. They are only going to need you for your senses. They don't have the ability to create. They don't have that creative ability. They don't have the ability to love. They don't have so they're going to put that quantum, they're going to put quantum in people's brains and probe their brains. You heard the dude, go back. Take it back. It ain't rewind no more, but go back. I guess it still is rewind. Oh, like I say, Lord, come quickly. Because that sounds like a living hell. That sounds like I only exist to be a slave, so these people can cipher my essence. You got to be watchful for devils trying to cipher your essence right here, right now. People see a light in you, and they don't quit coming at you till they think they can, till they get you to a point where they can snatch you, where they can yank you. But this is, if people are having a hard time breaking away from Easter, Christmas, Thanksgiving, 4th of July, President's Day, all of these old bull jive holidays, what you gonna do with this? You trapped. If you get here, you are in a living hell. And on that note, I believe I've said everything that I need to say. I always say that. And then at the end of the video, I say, ooh, I should have said. But I do believe I've touched on everything that needs to be said. The Lord always does these videos to perfection. And on that note, may the Lord be with you.